Hello everyone and welcome to this presentation of our paper entitled Effects of Viewpoint Oscillations and Gaze-Based Stabilization on Walking Sensation, Embodiment, and Cyber Sickness in Immersive VR. So as you know, when you walk, your head oscillates in space, as illustrated here. And this physical head motion may be implemented in VR as a visual stimulation, which is what we call viewpoint oscillations. So here is an example of implementation. And this is particularly used to enhance walking simulations, especially when the user does not perform such a physical head motion, for instance, in a seated posture. And we conducted a survey on the topic earlier in 2024, which led us to this contribution. So our motivation for this contribution was that we had little knowledge on the effects of viewpoint oscillations on embodiment, and that mixed results were obtained concerning cyber sickness in past work. Moreover, when walking, your head and eyes not only translate in space, but also rotate to stabilize your gaze target in your field of view. And these stabilizing rotations have only been implemented in non-immersive VR. Therefore, this study is a contribution on stabilized viewpoint oscillations in immersive VR. So in the literature, several implementation methods exist to implement viewpoint oscillations. The first one is animation-based oscillations, which consists in taking the animation of a walking avatar to implement the oscillation, which has the advantage of being consistent with the animation, but the motion may not be natural. Then tracking-based oscillations consist in using recordings of real people walking to generate the oscillation, which is natural, but may contain artifacts that require pre-processing. And finally, model-based oscillations consist in using mathematical functions to simulate this oscillating motion, which makes them smooth and periodic, but like animation-based oscillations, may not be consistent with the walking animation or natural. Moreover, the stabilizing rotations of the head and eyes have been implemented, as I said in the motivation, only in non-immersive VR. As for the effects of viewpoint oscillations on user experience, past work has shown that they increase walking sensation, especially in non-immersive VR, as results in immersive or embodied VR were less clear. Concerning cyber sickness, the literature has shown both positive and negative results, which means that viewpoint oscillations have increased cyber sickness in some cases and decreased cyber sickness in other cases, which is discussed in our survey. And a single study was conducted on embodiment, which reported no effects on ownership and a decreased agency with a first-person perspective avatar. Concerning the use of stabilizing rotations, the study that was conducted in the past showed that it could increase walking sensation. In this context, our contribution from a technical standpoint is to implement natural and comfortable viewpoint oscillations to simulate walking in immersive VR by designing biomechanically inspired oscillations using a mathematical approach and a stabilization of the field of view with gaze tracking based rotations. And from an experimental standpoint, we evaluate the effects of viewpoint oscillations on user experience by comparing stabilized, unstabilized, and no oscillations, and assessing the effects of these stimulations on walking sensation, embodiment, and cyber sickness. So concerning our implementation of viewpoint oscillations, for translations, we wanted to have a good trade-off between the naturalness of our implementation and its predictability and smoothness. So we designed a formula based on the results of a study in biomechanics, which results in such a virtual motion. So here are the translations in all three directions of space, and here is the resulting pattern of oscillation viewed from the top, back, and right. Concerning the stabilization of the field of view, we followed a simple process in three main steps. Firstly, we applied the translation that I just described to the camera. Then we scanned the virtual environment to find the target of the gaze using the data provided by the gaze tracker. And finally, we applied rotations to the camera so that the direction of the gaze would be aligned to the gaze target in this new camera position. As a result, when using our stabilization technique, no matter the position of the camera, which changes due to the translations that we apply to it, the gaze direction is always aligned with the gaze target, whereas without stabilization, the gaze target moves in space. So to assess the effects of our stabilization technique and provide new experimental data concerning the effects of viewpoint oscillations on embodiment and cyber sickness specifically, we conducted a user study. This user study compared 3 conditions. So the first one is a condition with a linear motion of the viewpoint, so no oscillations. Then a condition with oscillations but no stabilization. So as you can see, the green dot, which represents the target of the gaze, moves in space because of the viewpoint oscillations. And a third condition with stabilization and oscillations. And as you may see, the green dot is stabilized in space, which means that the target of the gaze does not move. We compared these 3 conditions in counterbalanced ordering in a within subject's design, and participants, as you can see in the videos, were instructed to look at highlighted objects. So in the results, we found that walking sensation was higher in both conditions with oscillations compared to the linear condition, and we found no significant difference between both conditions with oscillations. So this does not confirm previous results that stabilization increases walking sensation, and this may be attributed to the fact that the experimental setups were quite different between our study and the previous one, in that the display used was not immersive and no walking avatar was used, which may, in our study, have overridden this small benefit for walking sensation. Concerning cyber sickness, we identified no significant difference between the conditions and an overall low level of cyber sickness. We expected the stabilization technique to reduce cyber sickness, since we expected the fact that no motion of the gaze target would be less disturbing, but it was not confirmed by the results. Concerning embodiment, we identified an increase in ownership in the stabilized condition compared to the linear condition, and we found no significant difference in agency. This actually contradicts previous results on the effects of viewpoint oscillations on embodiment, as the only study that was conducted on the topic found a decreased agency and no effect on ownership. So this is clearly not the case in our study, and the results of our study actually show that viewpoint oscillations may be beneficial for embodiment. So in our paper, we discuss the reasons that may account for these different results. Some aspects of our paper could be considered as limitations. For instance, the instruction to look at highlighted objects, which in our opinion was necessary to enable comparison between the conditions, but may have prevented us from assessing the robustness of our stabilization technique, which could be assessed in future work in more ecological contexts. We could also have investigated other metrics of user experience, such as presence and vection, and technical improvements could be brought to viewpoint oscillations in future work, such as bringing a customization of the oscillations to users' walking style, to implement variations for turns and accelerations, and take into account the user's physical head motion. So to summarize this contribution, we designed stabilized viewpoint oscillations, which comprise natural translations of the viewpoint and a stabilization of the field of view with gaze tracking based rotations. We conducted a user study that showed that viewpoint oscillations in general increase walking sensation, possibly ownership in some cases, and do not seem to have an effect on cyber sickness. The study also showed that although it did not bring substantial benefit to user experience, our stabilization technique was feasible. And in terms of applications, viewpoint oscillations and stabilized viewpoint oscillations, since they rely only on the use of an HMD, can be easily implemented in future walking simulations. So I thank you very much for your attention.